In this demo, we've preloaded the platform with synthetic reports, photographs, commercial telemetry data, and satellite imagery. The ingestion models can recognize most data without any configuration, so uploaded data is usable out the box. Links between datasets, such as common fields, are visible in the Datasets panel, which grows with your data holdings. The Search Parameters panel also shows saved entities and areas available to analysts. New data can be added to the system via drag and drop, or, for larger datasets, via API or S3 dump. Now we progress to search and analysis. Here, we're investigating a particular region that, in this notional example, has been connected to hostile reconnaissance. We can retrieve data from areas of interest in several different ways, including via common geospatial referencing systems such as H3 and MGRS. Here, we'll pick a grid square. With the location in context, we can ask the AI questions, and it will reach into the tool ecosystem to answer them. After a short wait, the AI retrieves a summary of entities at the location of interest, providing links to the source reports. We can visualize each of the original sources via embedded links. We can also retrieve and visualize raw data, in this case Arabic reports, via a quick manual query. To demonstrate the platform's multilingual support, we can briefly switch language to Arabic. This will convert the user interface into our language of choice and prompt the AI to communicate accordingly. Asking for a summary of our retrieved results now renders all output in Arabic, and, as before, we can inspect and verify the results. Continuing our investigation, we can now switch back to English. Now we leverage the most powerful feature of the platform, the intelligence agent. Here, we'll look for entities within the selected area that have been discussed in the context of spying and have connections across their network linked to militant groups or in Iraq. The agent will decompose the request, identify appropriate data and methods, then recommend an analysis plan. Each step in the plan entails a specific analytical task and can be verified. Here we can see the locations where the agent intends to search, the keywords it will use for semantic retrieval, the overall nesting, structure, and logic of the plan, as well as the data and methods selected. When we're ready, we can run the analysis, returning results in several different formats. We can see a list of candidate entities, including people, reports, and vehicles. We also get AI summaries explaining how entities relate to the investigation with links to evidence, and comprehensive lists of original source documents. We also get network graphs for retrieved entities. Data types are color-coded for ease of inspection, and the focal entity is highlighted with white rings. We can see that the focal entity, Amir Hosseini, was seen in the grid square defining the area of interest and has text matching espionage-related terms. We can see his relationships, the source materials used to infer them, and the specific origin of the link, which can be co-occurrence, shared locations, or co-location in time and space. We can expand out the network by right-clicking on nodes. Here, a geotagged organization called Gulf Logistics comes into focus, which lets us visualize its headquarters on the map. Continuing the expansion reveals that Gulf Logistics is connected to Hezbollah. Stepping back, we can see that Amir Hosseini is connected to Hezbollah via a string of relationships spanning vehicles and companies. We can automate the process of expansion with a single click and let the AI build out the relationships further. Here is a suitable time to bring in a risk visualization. This tasks the AI to examine each node and assign risk status based on the parameters of our analysis plan. Here, we can see that a cluster of mobile devices linked geographically to Gulf Logistics have been flagged as being present in Iraq. Tracing the pattern of life of a device reveals travel history and loiter locations, which we can inspect. Back in the visualization, we can review risk across the network and zoom in on the mobile phone nodes. The tight grouping implies an operational or social unit, and we can confirm this by visualizing meeting locations for the entire network on the map. The AI has identified centers of gravity. Inspecting these confirms our suspicion. A dense collection of signals exist in southern Iraq, a known location of militant activity. We can dive deeper by retrieving a tile of satellite imagery, which appears to show a build-up of vehicles and tents. We can jump between the network's centers of gravity to inspect them, or zoom out to get a geographical overview. With evidence of a complex threat network across our results and network analysis, we can now task the AI to build a report, which can be downloaded or shared.